as Q naught is less than C, so the charge will be Q naught plus Q. And the charge here be Q. This Q I'll put red color. There's a charge which is going to be placed in the capacitor. So the capacitance of this is C naught. Let this be C. And a current I will flow like this, plus minus. There's a positive plate, there's a negative plate, and there's a EMF. So write down the loop equation, plus E minus IR minus Q naught plus Q by C naught minus Q by C equal to 0. So we want expression for current as a function of time. So what to do with Q naught? So I'll differentiate directly this equation. d by dt R into di by dt. Q naught is constant, no? Some fixed value. Q naught is some fixed value. So Q naught by C, Q naught will be a constant. So that was some initial charge given to it. So Q is what? Variable. This will be. So this will be minus 1 by let me expand this, no problem. dq by dt minus 1 by C dq by dt, all set equal to 0. So EMF of cell will be constant, minus R di by dt. This will be Q naught is a constant, so this will be 1 by C naught into 0. dq by dt, so this will be 1 by C naught, 1 by C. dq by dt is what? I write I. Because what all this current is due to rate of flow of charge. Equal to 0, this one. So this will be R C naught C by C naught plus C di by dt is equal to I is equal to minus I, right? So di by I is equal to dt by C naught C by R C naught C. So negative sign. At t equals 0, we don't know that initial current. Let me call that as I naught. And at any time, let it be I. So this will become log of I by I naught minus t by this. Everything is say some, if you want, you can write lambda. Like earlier we proceeded. So this should be equal to, the final expression will be I equal to I naught e to power of minus t by lambda. This I naught is what we assumed it, no? So what should be that initial current? How to bring that one? So at t equals 0, you go for the equivalent circuit. So how to get that equivalent circuit at t equals 0? At t equals 0, that equivalent circuit is what we have to put it here. So at t equals 0, I'll draw the circuit. So where all capacitor, there's a resistor is there. So where all cell is there, let it be this EMF. And this capacitor was having initial charge, no? Replace that with an EMF, E naught. Small E naught, alright. And this capacitor was not having any charge, replace with a short circuit. So what you have to do, a capacitor, if it is having initial charge, replace with a cell with suitable polarity. A capacitor which is having a zero charge, replace that with a short circuit. I think this condition, if you remember, it's capacitor charged or uncharged, you can manage the problem very easily with this method. Look that initial current. Sir, why only you are picking up current in this direction? It all depends upon the value of Q naught. Q naught is greater than C naught E. Then the initial current I naught will flow in opposite. Then you put minus I naught. We are assuming that the initial current I naught will flow in the direction of the current at any time t. So therefore I am writing plus I naught. So when it will be minus I naught, when the drop across capacitor is greater than EMF. So then in that case minus I naught you can put it. So how to calculate this I naught? So plus C plus C minus I naught R minus E naught equal 0. So what is I naught equal to? E minus E naught by R. So what is value of E naught? We don't know anything E naught. So E naught is what? Q naught by C naught. Substituting this, we'll get the I'll write this equation here only. I is equal to so like this we can manage if there is even any initial charge is present, no? One charged, uncharged also. This is a method you can apply it. So just only it's a method, nothing big. Till now they didn't ask anything like this in advance. Possibility of asking. So substitute now. The value of I will be so the I naught will be equal to E minus Q naught by C naught by R or E C naught minus Q naught. Okay, I think the equation itself will tell you, no, if Q naught greater than E C naught, current will be in opposite direction. This value of I naught, you have to substitute here, you'll get expression for this one. So what is the current at any time? E C naught what is lambda? Lambda is everything, this one. This expression for current at any time t. Once you know current, you can go for charge. Okay, I think this is very important. I just replaced no capacitor. Where cell has come, there is only one cell. So why you brought another cell? The initial charge in the capacitor will have that potential difference. So that will be like a EMF. Sir, why this capacitor short circuit? If the capacitor is having a zero charge, replace with short circuit. If capacitor is having an initial charge, replace with a cell, equivalent cell. With that, you should calculate the initial current. Now, I think the total, the description, what we had is this one.
Sir,
Yes, ma.
by C not, sir.
Which one? Which one by C naught? Ah, here, one C naught will be there, no? Okay, okay, fine. Yeah, thank you. So this will be